Here we go, we have a question nearly sorted. So you have given an array where each element is at most k distance away from its original target position, and you need to sort the array optimally, but we cannot use the predefined sorting algorithm, and the note here is you need to change the given array itself in place. So we do not need to return uh, a new array, we just need to change the input array in place. So we have this example, the two input position is this, but two correct position is 0. So the 2 is 3 distance away from its target position. Then we have 5 position is this in the target array, but its position is 1, expected position is 2, so it is at most k distance away. So that's the overall problem description. So let's try to build the approach. We have this example, and first, this is our 2 have to be here. So we need at most 3 elements, actually 3 plus 1 elements, because this its correct position is this. So we need k plus 1 elements, then only we can find a element and place a element in its correct position. We need k plus 1 elements, we need k plus 1 elements, and after that we need to find the smallest element. So first data structure, first thing that come to my mind is data structure known as priority queue. So we're gonna use priority queue. First we iterate till here, till k plus 1 times. So we have 6, 5, 3 and 2 in our priority queue, and this is my I then I will add current element, I is here, then I will add current element, I will add current element, then I is here, I added the current element. Then we have k plus 1 elements, and it is k distance away from its target position. So we need to find the smallest element, and we need to place here, we need to first place on the jth index. J is 0 initially. So first element, the smallest element is 2, the smallest element 2 is 2. So we just need to change the value with 2, and then increment j pointer. Then 2 is in its correct position, and we just removed 2 from our priority queue. Then I will increment I is here, just add the element, find the smallest element and place the smallest element, then increment your j pointer. And I forgot to remove from our priority queue. Then I considered the ith value, I will increment, value is 10. So here we have 10, I added 10, then smallest value is 5. So I will remove 5 and place 5 on the jth position. Then I will increment j value, j value is here. Then I will increment, I is here, add your current value which is 9. After adding this value, we need to place the smallest value here which is 6. So I will place 6 here, then j will increment, j is here, then I considered the ith value, then I will increment, then I is equal to n. We have 3 more values and j is also here, so we need to place 3 more values, first on the jth position, then j will increment. So value is 8, j will increment, value is 9. So I remove value and place value, j will increment, remove value, place value. So now we have a sorted array. So that's how this algorithm will work. We're gonna use priority queue. So let's build this, let's code this. First we have a priority queue, then find n, and we have j. So we have a loop, I added the current element, which means ith element in my priority queue. Then if I is greater than or equal to k, means we have k values in our priority queue. So then we're gonna pop a value and place on the jth index. Then we have some more values remaining in the priority queue. So we just need to place the value by removing from the priority queue. So let's submit this. And here let's talk about time and space complexity. Time complexity is very simple. Time complexity is order of n, and sorry, space complexity is, so let me think a little bit. So first let's talk about time complexity. So time complexity, first we have for loop and for loop. Here time complexity is order of n, but we have priority queue also, and in the priority queue we have at most k values. So we are adding, we are iterating n times, and for adding a value we have log, and in the priority queue we have k elements. So its total time complexity is n log k. Space complexity is order of k. So let's find out if we meet the expected space complexity or time complexity. Yes, time complexity is n log k, space complexity is order of k. So if you like this video, give it a thumbs up to boost my confidence, and subscribe to this channel. Thank you all for watching.